a lecturer in Ahmedabad High School and the Junior College. Welcome to the series of the lectures of Intermediate First Year Chemistry. We have been discussing the different concepts of atomic structure. We have started with the basic subatomic particles, we have continued with the different models of atom, that is we have started with the models of Thomson model, Rutherford model and Bohr's atomic model. After that, today we are going to discuss the different properties such as we have been discussing the basic things such as photoelectric effect, right, dual nature, electromagnetic nature, right. Today we are going to observe the main concept, that is its radiation frequencies spectrum. What actually a spectrum mean? We have discussed that each and every electron or whatever the element it radiates, or whatever the particle it radiates electromagnetic waves, right. Based on its state it will radiate different kinds of energies, that is different energies of different frequencies, right. That energy of frequencies is always within a fixed frequencies of range, that is the Vibgyor range, right. We have discussed in our previous classes, that is it always distributes in a fixed spectrum, right. What actually a spectrum is? A spectrum is a band of frequencies together is called a spectrum, that is what we know. And after that, what is a continuous spectrum? A continuous spectrum is a band of frequencies, that is we know that the frequencies are always in the range of fixed limit, that is from the starting from the violet range to the red, right. That is a Vibgyor kind of spectrum, isn't it? That continuous kind of whole frequencies is called as continuous spectrum, is it okay? And the next is a emission spectrum. What is an emission spectrum? What is an absorption spectrum? That is an emission spectrum is the set of frequencies when an electron emits energy, right, which means the frequencies in which the electron releases the energy, that is emission spectrum. What about absorption, right? Whenever the electron or some particle accepts some energy or absorbs some energy, that particular frequencies of energies are called as absorption spectrum, isn't it? And the next is line spectrum. What actually a line spectrum is? See here, there are few particles which does not radiate or which does not absorb in a particular frequency. What kind of frequencies are those, right? At those particular frequencies, the whole spectrum will give a band, black kind of frequencies, which means it will have a one or two frequencies left in between. That is those frequencies or those frequencies are called as line frequency, and the set of those all are called as line spectrum, right. What is the main interest in the line spectrum? That is a line spectrum consists of one or two frequencies which is actually very important to analyze, which is easy to analyze. That is why there are many theories behind this line spectrum, right. That is why most of the scientists they started to experiment on line spectrum of hydrogen. Why only hydrogen? Because hydrogen is one of the most lightest atom. Hydrogen is one of the most lightest atom, isn't it? Lightest in the sense its atomic number is only 1, practically thinking it has only 1 electron, 1 proton kind of thing, right. That is why whenever energy is given to a hydrogen molecule, it gets dissociated, because the each and every atom of hydrogen molecule, that is if it is H2, the 2 atoms of hydrogen molecule they get excited to higher energy levels. What happens when they get excited? When they get excited, they start radiating, right. Whatever the energy spectrum it is there, whatever it is there, when it reaches the higher energy level, will it stay there? No, nevertheless an energy, I mean the electron or a particle can never stay in the higher energy state, it has to retain back, right. Then in what sort of energy will it radiate, right, is it clear? See here, we discussed that whatever energy which is there, it is always released in terms of quanta, it is always quantized, that is the Planck's quantum theory, right. Similarly, here also the hydrogen, whatever it is there, the hydrogen whenever it gets excited by taking lots of energy, it has to come back or it has to get neutralized by releasing its energy, right. See here, based on the quantization theory, we can tell that the whole energy is released in a discretized way, that is it will release in discrete frequencies based on the excitement it has, right. Will it directly come to the neutral state or a ground state, right. It will release in different frequencies, right. Based on it, there are few scientists who discussed a few things, that is a Balmer is a scientist who tells that the wave number of a frequency of a radiation or a wave number of a radiation is always given by 109,677 into 1 by 2 square minus 1 by n square, right. What is this n? N is the number of frequency or the number of energy level from which it has to fall down, that is 2 is other than 2, more than it should be more than actually 2 or 3, okay, that is n. Is it clear? There is a fixed constant value for most of the atoms, right. And one more thing is the next scientist was Rydberg. He generalizes this equation, like he takes n1 and n2, right. There is the first energy level and there is the second energy level, right. Based on these things, he tells that whatever the electron or a particle, even it jumps to infinity energy level, it has to fall down either to 1, 2 or among them, either it is n3, n4 or kind of thing. He divided the whole thing as different discrete levels, right. Based on this constant, he named this constant as Rydberg's constant, and this equation is Rydberg's equation, right. Is it clear? See here, he tells that a Rydberg's equation is valid for different series, that is when an electron or a particle is jumping from higher energy level to, if it is n1, he named it as one series, if it is n2, he named it as one series, if it is n3, n4, n5, he named for the first 5 energy levels. Let us see what are those. See here, there is a hydrogen spectrum, these are different energy levels, that is there is a ground level, that is the first n equal to 1, 2, 3 and so on, that is an electron can be either excited to higher levels, whether it is 2, 3 or 4 whatever, right. It has to come to the neutral state, right. That is whatever, for example second level to first level, that is this, or third to first or fourth to first or fifth to first, whatever it is, if it is coming to the ground, I mean n equal to 1 from 2, 3 or whatever, that series they defined it as Lyman series, right. This kind of frequencies are always in UV spectral region. Similarly, Balmer region is somewhere from third, fourth, fifth to the second energy level, right. Those all coming to the second energy level. This kind of frequency radiation is given by Balmer, where they finally come to the second energy level from different higher energy level. This frequencies come under visible. Similarly, Paschen, bracket and Pfund. There are different kinds of frequency spectral regions and frequencies, and the series they name themselves. Is it clear? This is how they define a simple line spectrum of hydrogen. Okay. What are the different theories we discussed before Bohr? That is starting from the EM radiation, that is dual nature of a particle. Then we have discussed the photoelectric effect, Planck's quantum theory, kind of different things. Now let us start our practical model. Actually it is the most popular model and it is the most important model, that is Bohr model. Okay. He also described hydrogen atom. Based on all these conclusions, he explains the particle structure of a hydrogen. He takes the basic principle of hydrogen, the basis of line spectrum and everything. Okay. Let us start. Now see here, what is a Bohr's atomic model? Bohr's atomic model, you have studied postulates and everything in our previous sections. Let us have a deep description of what is a Bohr's atomic model based on the concepts which we learned, right. Bohr tells that according to him, the electrons in an hydrogen atom, revolves around nucleus in a fixed path, they are called as orbit or shells. Is it clear? Is it right? He tells that an atom is always in a spherical in shape. An atom is always in a spherical in shape, and he tells that whatever the electrons are there, they always revolve around this particular nucleus in a fixed path. The electrons revolve in a fixed path. They are called as orbits or shells. Is it clear? The electrons revolve around this nucleus in a fixed path called as orbit or a shell, right. What is the first point? That is, an atom is spherical in shape and the electrons revolve around nucleus in a fixed path called as orbits or shells. And one more thing, whatever electrons which are there in the shell, they remain in the same place, right. Until and unless they get energy, they will not move, which means they are fixed in that particular place, right. Can I use the term stationary? Yes, even he tells that as long as the electron is in the same shell, the energy is constant. That is, as long as electron is in the same shell, its energy is constant. That is why those are called as these energy levels or shells, called as stationary orbits, or stationary shells. Is it clear? What is my second point? As long as the electron is in the same energy level, its energy is constant. That is why they are called stationary orbits or stationary shells. Is it clear? Whatever it is, if it want to jump from lower energy to higher energy level, what it will become? If it want to jump from lower energy level to higher energy level, that is, if it is in the lower energy level, it is very near to the nucleus, which means the nucleus will be attracting it. It needs more energy, right? It needs more energy to get out of that attraction. Is it okay? It may not get out, but it can move away from this nuclear attraction. It needs some energy, which means when electron jumps from lower to higher energy level, it requires energy, which means when electron jumps from lower to higher energy level, it absorbs energy, right. Similarly, when electron jumps from higher energy to lower energy level, what it will become? It has to radiate some of the energy, that is, it has to release some of the energy. Is it okay? This energy, whatever this energy, there is also the point or the part of this, whatever the energy, whether it is absorbed or radiated, it does not take in a continuous manner. It does not happen in continuous manner. How does it happen? It happens in a discrete way. Is it clear? How does it happen? Whatever the energy is released from higher energy to lower energy is always given by h nu, right. This is actually called as Bohr's frequency rule. How did he get that? We know that nu is nothing but change in energy by h, right. Then this energy change, that is, when an electron jumps from higher energy to lower energy level, it has to radiate some energy, right. That energy is always given by h into nu according to our Planck's constant. How does it radiate? It will never radiate in continuous manner. Then how does it radiate? It radiates at discrete levels, right. It radiates in a quantized manner, right. What are the points? First point is, an atom is spherical in shape, electrons revolve around the nucleus in a particular path called as shells or orbits. Since the energy is fixed for it, right, the energy is fixed for that particular orbit or shell, they are called as energy levels, right. As long as the electron is in the same energy level, its energy is fixed, right. That is why they are also called as stationary orbits or stationary shells, right. And one more thing is, when an electron jumps from higher energy to lower energy level, it has to radiate some energy, and it jumps from lower to higher, it has to absorb some energy, right. From this we can conclude that the electrons which are near to the nucleus will have very less energy, right. That means most of the energy is always used in maintaining the circular path, right. If it does not have energy, it has to go and it has to go and unite with this positive charge, isn't it? Is it clear? This electron should have some kind of centripetal force, right. Is it clear? Some centripetal or centrifugal force which combine together to maintain in the circular path. Is it clear? It should have some kind of centrifugal force to move away from the central element. Is it clear? That is why if you observe here, he tells that when an electron jumps from higher energy to lower energy, it releases energy in terms of h nu, right. He named it as Bohr's frequency rule, right. The next is, the fourth thing is, he tells that electron revolves around the nucleus with an angular momentum of integral multiple of h by 2 pi. What is angular momentum? That is mvr is equal to nh by 2 pi. Is it clear? See here, there is a circular path. Whatever the particle it is there, it should have some momentum to move around something, right. Since it is in circular motion, we are measuring the angular momentum, right. This angular momentum is always an h by 2 pi multiplied by an integer, right. That is mvr is equal to nh by 2 pi. What is this m? M is the mass of electron, v is the velocity of electron, that means the speed at which it is revolving. R is the radius of an orbit, where it is in this orbit or whatever, right. Here n is number of energy level, that is nothing but a normal integer 1, 2, 3 and so on, right. This have a special significance, let us discuss in next session. And h is a Planck's constant, which we saw in this Planck's quantum theory. 2 pi is a normal constant. Is it clear? Once again, the electron revolves with an angular momentum of integral multiple of h by 2 pi, that is given by mvr equal to nh by 2 pi. Can you understand? See here, once again let me revise everything. A Bohr's atomic model tells that an atom, and one more thing, remember that he explains everything in terms of a hydrogen atom. He is specifically referring only hydrogen atom. Is it okay? He tells that a hydrogen atom is always in a spherical in shape. Whatever the electrons are there, they are revolving around the nucleus in a particular path. That path is called as orbit or a shell, right. As long as the electron is in the same energy level, its energy is constant, right. That is why they are called as stationary orbits or stationary shells, okay. And one more thing is, whenever the electron jumps from higher to lower, it radiates some energy, and whenever it jumps from lower to higher, it absorbs some energy, right. That energy is released as radiation, which is given by E2 minus E1 as h nu, where E2 is the higher energy level, E1 is the lower energy level, h is Planck's constant and u is the frequency of radiation, and it is popularly known as Bohr's frequency rule. And the final point is, angular momentum of electron is always given by integral multiple of h by 2 pi, that is mvr is equal to n into h by 2 pi, where m is mass of electron, v is velocity of electron at which it is rotating, r is radius of a particular orbit, n is integer, h is constant, 2 pi is also constant. Is it clear? This n has a particular kind of significance. It can also be called as a principal quantum number. What is it? Why it is a principal thing? Okay, there is a basic postulates of Bohr's atomic model. Let us discuss about a few more constraints and its defects, right, in our next session. Okay, is it clear for today? What all we discussed in this class? We have started with the basic line spectrum, I mean different kinds of spectrum, what is spectrum, continuous spectrum and everything. Then we discussed what is the line spectrum of hydrogen. We have seen different series, Rydberg's equation, Balmer series, right. After that we started the Bohr's atomic model, we discussed more postulates and everything. Tomorrow we will discuss, I mean in the next session we will discuss few more theoretical concepts of Bohr and will end up with the defects of this. Okay, is it clear for today? Fine. This is for today. Let us discuss more concepts of atomic structure in our next session. Okay, thank you.